All right, so test 2 is going to be available. Please ignore the test Friday. That was just from a copy of notes. So topics on your test. First things first, we talked about derivatives using the limit definition. So if you go back to your notes for 3.1, right, we did various examples where we found derivatives. Right, here we did derivative of 3x minus 7. So limit definition means you're starting the problem out like this, very much like the problems you've submitted or did the work and submitted it online for me to grade. So you're going to be looking with two problems on your test where you're asked to do the derivative using the limit definition. And it'll be very much like some of those ones that we did in the notes here or in the videos. Here we did 1 over x squared. We did square root of x, or similar to the ones that you might have done in the turn-in. Here we did a polynomial. This was a little more involved. So looking through those different examples like that, that's what you can kind of expect. There is one, I think, in the practice problems. That's one you don't have to turn into me, but it's just to kind of let you know the kind of problem. So what I'm looking for is that limit process. You write out f of x plus h minus f of x. Right, you're expanding that out, and going through that process there. Again, as you can see here, we went through and we expanded it out, simplified. Right, eventually cancel out the 0 factor to get our result. Allow h go to 0 and get our result. So you're going to have two questions where you're asked to do that, and I do ask to see your work for those to verify that you did use the limit process. Using the shortcut rules won't count on these problems. Okay. And then next up, I kind of lump all these problems together, 3.3, 3.4, 3.5, and 3.7, because they're all involving derivatives using our different rules. One thing I can tell you for sure, in 3.4, 3.5, we're talking about derivatives of the trig functions. You had some problems that you worked out and sent to me or worked out online and I graded, where you had to do the derivatives of a couple of the trig functions. In the 3.4 notes, we also did a couple of examples as well. We'll have a question on your test where I ask you to use the quotient rule to develop the derivative of one of those trig functions. But let me just quickly give you kind of a little look back over the notes here. As we talked about derivatives, first we had our more basic derivatives just using the sum, difference, and power rules, right, where we can just distribute our derivatives through. I wrote a lot of work out for some of those early examples. You don't have to write out all that work or anything like that. Just basic derivative rules. We also saw some problems that later on we could do with like a product rule, but a problem like this where it's actually easier to do it algebraically. Same thing with this division problem. We could do it later with the quotient rule, but it's probably just as well to do it by dividing first, doing some algebra first. And of course, we talked about what it meant for something to be differentiable, right? Its derivative exists, so that doesn't happen at sharp points. That doesn't happen when you have either a vertical asymptote or an infinite tangent line, or with piecewise functions when you switch from one point. It's not a smooth curve. We then talked about the notations for higher derivatives. We did some quick examples with some higher derivatives. Through some examples doing that. Okay. And then again, as we talked about in 3.4 with the quotient rule, we did the derivatives of tangent and secant. You did the other ones, cotangent and cosecant, as turn-in problems that you submitted. So you expect some questions where you have products or quotients, right? And we have to do the derivatives. Like here we did x squared sine x, or cosine squared, or here's one where we actually could multiply it out, but we did it using the product rule just as practice. And then we got into some examples with the quotient rule. Again, some of the first few examples we could do without the quotient rule by some algebraic rewriting. And then we got into ones where we did have to use the quotient rule. So you can expect a variety of questions where you have some product rules and quotient rules, like out of 3.4. 3.5, of course, involving the trig functions. And then 3.7 is when we get into the chain rule. Remember the process of the chain rule, it's the derivative of the outer function times the derivative of the inner function. And so you'll have some chain rule questions where you're just doing the derivative with the chain rule. And then you'll also, though, have some problems as we got towards the end where we had chain rule as part of a product or quotient rule. And pretty much as you can see in this example here and in the other ones that follow in the 3.7 notes, right, pretty much guaranteed that you're going to have some type of factoring that you'll need to do to simplify these chain rule problems to get a nice final answer. In this case, our nice final answer was just literally 4x cubed times 3x minus 2. It actually worked out to be the case there. Was what the top became. And I think finally, just got myself lost on my notes here. Oh, I'm sorry. I was just showing where that how that factoring happened here. So we got the result, of course, right here. Sorry, I got myself lost for a moment. Another example, here's a quotient rule where we also have a chain rule involved. Another quotient rule and chain rule. Here's one where we actually could do the quotient rule or we could rewrite it since we have a constant up top and just use our chain rule only. And then we had this example with some trig functions mixed in there as well where we had the product and or in this case, the chain rule and a quotient rule is the way that I worked this problem out. Although you could distribute the square through and do it with two chain rules as part of the quotient rule as well. Okay, but you can expect, a variety. You'll have some chain rule where you're just doing the chain rule itself, and then you'll have one or two at least where you have the chain rule along with either a quotient or a product rule. Okay. And expect as well at least a couple questions where you'll be asked to do some higher derivatives. And there'll be at least one question where you're asked to find the equation of the tangent line for some kind of curve. Okay. In 3.8 we talked about implicit differentiation. So there'll be one question where you're asked to find the derivative implicitly. At least one, there'll be a couple questions where you're asked to find the derivative implicitly. And then there will be one where you are asked to find the second derivative. So if you go back through the notes, we did some examples here where we were finding the derivative. In this example, we did it both implicitly and explicitly to see that they actually agreed. Here we just did explicit or implicit differentiation to find dy dx, and some various other examples here with implicit differentiation. Okay. We then turned around and wanted to find the second derivative. Now, some of those derivatives we got here with implicit differentiation were pretty complicated. Y prime equals that big old mess. Y prime or dy dx equals this big old mess here. And we wouldn't be doing a second derivative with these things. These are just too complicated to really want to deal with. So when you're asked for a second derivative, it is going to be with something that has a pretty nice first derivative. So here, our first derivative was 14x over negative 14x over y. And we find the second derivative. And what you usually will find with the second derivative is at some point, your original equation will often come back into play and allow you to simplify that second derivative to something even simpler. Okay. So it won't be something overly complicated there for the second derivative. And then the final thing, what we talked about here in 3.9, and that is the related rates. So if you go back through our examples here with the related rates, there'll be one problem where you're given a formula with a related rate. So we did some examples with a balloon being inflated. So we have the volume formula for a balloon to get the relationship. Here we did a problem where we were we're draining water, I think, out of a cone, or filling a cone up. So actually, I think we were draining it. Water was coming out of the coffee filter. So here's the volume, and again, that formula, if you needed it, would be given to you. And then we did a couple of examples where we had to actually build the relationship. So here we saw this example with a ladder against the side of a building. The ladder was being pulled away. Here we did an example with a shadow where we had to use similar triangles. And here's another example with a boat that's being dragged in. Again, here you're using Pythagorean theorem in this particular case as well. So you can expect that you'll have one where you're having a formula that you can use work out the related rate. One, you're going to have to build the relationship from the information. And again, that'll either be something with the Pythagorean theorem, or it'll be something with similar triangles like this example with the shadow. Okay, that in a nutshell is your test. If you do have questions, please let me know, and I'll try to help you out as best I can. Please show your work with the test. I will go back once you've submitted your work to the proctor, and I will regrade any problems that you missed. And again, there are problems on this test with the limit definition and with the derivative of a trig function using the quotient rule, where I am going to need to see your work to grade that. Okay, but any other problems that you miss, I will go back and grade your work to give you partial credit on those problems. So again, any questions, please contact me. Good luck.